right, let's talk about plotting points or plotting coordinate pairs, which is section 1.5 in the Mercer-Sabecki book. We're going to map some coordinate pairs, and we're going to connect and interpret data with the graph itself. Okay, I have a few recalls. We have done some visualization of data before, and we're going to do this again, but in a different way. My first recall is this. Bar graphs also allowed us to visualize data. So bar graphs allow us to visualize how frequently. So remember, our vertical axis was always how many, or relative frequency, which was the percentage of. But bar graphs allow us to visualize how frequently something occurs. Okay, and then it paints a picture for us. We can sometimes see more relationships if we have a visualization of what's happening. Another recall. The explanatory variable is traditionally on the horizontal axis. So if we know that there is an explanatory and a responding variable, then we like to keep them or assign them a location. Okay, in the bar graph, it was categories. Okay, and then in response to that is the respond. Okay, so the response variables, or dependent variable, if you want to call it that. We assign to the vertical. And again, that's if we know that one is independent and explaining the other, and the other is responding to that explanatory variable. Okay, and then my last recall is this. It's about coordinate pairs, because we are talking about plotting those pairs. So remember that coordinate pairs keep track of values that correspond to each other and go with each other. So I was right, they like 2 and they go with each other. They're what the explanatory followed by the response in 2D space. So corresponding pairs. Why did I write corresponding? Because I'm thinking about, okay, it's fine. Coordinate pairs. Keep track of values that correspond to each other. It's like I started writing coordinate, and then my mind immediately went from coordinate to correspond. And I like to think of these as coupling. A coupling of the explanatory with the response. All right. From page 63 of your textbook, they have this chart, and immediately I want to fill it in. I'm going to zoom in just to make it a little bit larger. Here it says how many years after 2006 is this? Well, this is 0 years after 2006. This is 1 year, 2 years. Are they counting? They're counting by 1 year each. Okay, so this makes it very nice and predictable here. So 2014 is 8 years after 2006. That makes sense, just to make sure we're doing this right. And then 2016 is 10 years after 2006. Got it. And then they want us to write these as an ordered pair. Where, okay, again, I mean, this is kind of vague in your textbook, but what they're really saying is, okay, X is the independent or explanatory variable, and really time is independent of the price per gallon in the United States. Okay, so this data is the average price of unleaded gasoline in the United States recorded in January. So, what year was that? Anyway, okay, the year would have been helpful here, but the price per gallon does not explain what year it is. The price per gallon is responding to the time. So he writes, or they, I'm sorry, they write X and Y, but I really prefer T, and I really think that this is the explanatory variable. Time, the price per gallon is responding to the time. So price per gallon, I'm going to give P for price. And I could have called it G for gas. But this, to me, is the response. And so then we order it explanatory with response. So here, ordered pair, 0 and 2.32. 1, 2.27. Got it. 2, 3.05. 3, 1.79. 4, so 4 years after 2006, which is 2010, corresponds to the price per gallon of $2.73 per gallon. So, went up quite a bit from there to there. And it actually went down quite a bit right there. Okay, anyway. Oh boy. Okay. Let's see. 5 years later, it's $3.09. 6 years later, it's $3.40. 7 years later, it's $3.35. 8 years later, $3.32. 9 years later, $2.11. And 10 years after 2006, it is $1.97. Got it. Coordinate pairs. So I wouldn't write something like 4 with $3.32 because that would be interpreted as the average price of unleaded gasoline in 2010. Oh, here we go. There's the years. I was silly for saying that earlier. In 2010 in January was $3.32, but it wasn't. It was this. So these really do correspond to each other like a couple. This one goes with this, and you belong to them. Yeah? Okay. Number 1, fill in the table with the missing values. Check. Number 2, plot the coordinate pair that aligns with the data from 2012. What choices do you make when plotting? Did plotting that point give any additional information? Okay, there's a lot there. Let's pick it apart. Plot that coordinate pair. So 2012, we have the pair 6 and $3.40. So let's write that down. So six with 3.40. Okay. Well, I just have a random generic axis here. I noticed that the highest gas price on here, is that the highest? It looks like that is the highest. It is. And okay, so the highest is just under 350, and it can't go below 0, otherwise they would be paying us to get gas. And let's see. Okay, so it can't go below 0, and it has to go up to 6. We could keep that all jammed in here and label everything between 1, 2, 3, 4 and have a tiny little visualization here. But then, I mean, our years go up to 10. So this would be 1, 2, 3, 4, 5, 6, 7. We would only be able to go up to 7. So usually when that happens, what I like to do is I like to take it back. So if this is 7, let's go 8, 9, 10. Okay, so what I'm going to do is I'm actually going to move my axes. I realize that we're only plotting this one point, but our this goes up to 10 in our explanatory variable, which is the horizontal axis. So I wanted my horizontal to be able to have at least 10. And if I move this over here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, I make it. So I'm actually going to make the first decision to realign my axes. And then let's see, to plot this, I don't know. So do I want to move my other one? Let's go. I could, if I move it down a little bit, because all of these are positive. So I'm also making the decision that the lowest one is 0, and they're all pretty close together, so it might be nice to count by quarters, but maybe I have to count by 50 cents. So $half. Let's see. A quarter's up to 350. I'm actually going to take 350 and divide it by 25. That's 14. Huh. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Oh boy, I'm going to move it all the way to the bottom. Okay. So, my first decision actually, did I make choices? What choices did I make? I just decided to move my axes. Okay, so my horizontal axis is the years after 2006, and my vertical axis, which is the responding variable, is the average price per gallon. So average price per gallon of unleaded in January. There we go. Whee! Okay, and now I've made the decision to count up by 25 cents. So it would go, okay, here would be 0 and 25, 50, 75, $1. $1.25, $1.50, $1.75, $2. $1.25, 50, 75, $3, and this would be $3.50 at the top. Okay, so, and that's price per gallon, remember. So $1 per gallon, $2, $3 per gallon. And then this is 0, and I'm just going to count by ones down here because I need to go from 0 years after 2006 up to 10 years after 2006. So we'll just go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, super. Now I'm ready. Okay, so right off the bat, most of my choices actually were how do I assign my grid, and then how do I label it. So I made some choices, and now I'm going to plot this pair. 6 years after 2006, which is 2012, it cost $3.40. Okay, well, so this is $3, this is $3.25, and that's $3.50, so it's somewhere like that. There is our coordinate pair that aligns with the data from 2012. Okay, got it. It says, did plotting that point give any additional information? No, I don't think so. I mean, it's right there. It's just one data point, so no, I don't really feel like, no. Here, I'm gonna put this. Okay, we just did all of that work to get not much return. So, not really. Plot a point for each data value. Each of the data values in the table. Okay, your book gives you this, and notice that they chose also to go from 0 to 10, and they went by $half. Now, believe it or not, this is great, and you could fill in this grid, but I think that this is actually going to be a little bit easier for me because I went up by quarters. So I'm going to use this grid actually after moving the axes. So here we go. Okay, we have the point 0, $2.32. 0, $2, that's $2.25, so just above it. Got it. And we have the point 1 and $2.27, so 1, 2, $2.25. Wait. Okay, that's $2, $2.20. Okay, my bad. So very similar, but just slightly above $2.25. I almost made a mistake there. And then we have the point 2008, which is 2 years after 2006, and that was $3.05. So 2 and 3, that would be $3.25, so that's just over. Got it. And now I'm going to move a little bit faster here. So 3 years later, $1.79. Well, that's $1.75, just above that. 4 years later, $2.73. So pretty much on $2.75. So $25.50. And then at 5 years later, it was at $3.09. So here's $3, $3.09, like that. 6 years later, it was at $3.40. Oh, we already have that point. There it is. 7 years later, it was at $3.35. So here's $3, $3.25, $3.35. 8 years later is at $3.32. $3.25, 32 cents. Very similar. And then 9 years later, which was 2015. $2.11. $2, and that would be $2.25 is right about in the middle. And 10 years later, $1.97, which is just under $2. Got it. Okay, so here is our scatter plot. Oh, it's very chaotic. So, and just so you know, this image, right, would appear very similar here too. It looks like maybe this just would have been spread out a little bit more. So there would have been more horizontal space between each one of these coordinate pairs. Okay. Does plotting all the data points give additional information? Okay, a couple of things. So when I look at this, and I zoom in, what I see is, I don't know, I mean the lowest, I see immediately the lowest it goes is just over $1.75. And so I see the minimum here. I also see the maximum right there. That's the highest it went in those 10 in that 10-year span. I see that it went Okay, it was pretty similar, but then it jumped, then it fell, and then it rose, and then it fell again. Okay, so I see this maybe increasing and decreasing situation where my eye starts to read from left to right, and then it goes up, then it goes way down, and then it kind of goes up, and then a little bit down, but then really big jump. So when I look closely, I see all of those. When I look far away, I see, they're just really right around this range right here. That's our trend. Our trend isn't really that it's like consistent, because I don't really see much consistency except for some jumps. But I do see that they're, around this band typically. So we can kind of predict where they're going to fall, kind of. Or at least give a range. Okay, so does plotting all the points give additional information? I would say yes. The first thing that my eyes went to, minimums and maximums, highest and lowest. It also tells me where is it increasing and decreasing. What else? Oh, it gave me a range. It told me, they're always about right around here. I didn't see any other trends like it's always going up or always going down, like this increasing, decreasing business, but I did notice the jumps. So sometimes I saw that. How about this? Jumps. Yeah, those kind of stood out to me. So when we visualize the data, we do see more. Definitely more than when we just see this raw data here and we're like, okay, here's a bunch of numbers. That's great. Great, grand, wonderful. But then when we see a visualization, we're like, oh, okay. So that's how it is. Pictures really are worth a lot in terms of explanation and realizing relationships and the like. So scatter plot is a data display to visualize the relationship between two varying quantities. Let's write that down. Data display. A data display to visualize the relationship between two varying quantities. Okay. Remarks. I have a few things that I feel like are pretty remarkable. And the first one goes back to the fact that we had, I'll include this one first. So my first remark is that a visual reveals more about relationships. And this is true about humans too. Like when we see a snapshot of two people and we're like, we can sometimes even just get a snap judgment of whether they're in a fight or not, or whether, they're joyous or, so pictures do reveal a lot, and that's the same with data. So a visual reveals more about relationships. Okay. My second remark is this. Equal spacing on each axis is necessary or else your visual is skewed. Okay, I better write that down. Equal spacing is necessary. So up here, I counted by ones. 1, 2, 3, 4, no hopping. Even between 0 and this first one, no hopping from immediately to 2 or immediately to 3. No can do. And the book did the same thing. Notice the equal spacing. They went by 50 cents here, whereas I went by quarters here, but still, equal spacing is necessary. or you'll get a skewed image. Okay. I also want to mention before I go to the next page to write my last remarks, I'll put it on here in pencil so that I can erase it. Scatter plots to me are also kind of a lazy way to do a bar graph. So I had put in the recall that bar graphs allow us to visualize how frequently something occurs. And this is just, I mean, it's the cost, but it is really, I mean, if at each one I could have drawn a bar, yes, and you would have gotten a similar idea. Okay, so instead of just plotting a little point, if we had made bars on each one of these, okay, so in my opinion, a scatter plot is very similar to a bar graph, except we just got lazy and we didn't draw the bars. Okay, we would see the relationship at the top of the bars. So, just FYI. Okay, I'm lucky that this still has an eraser. Pencil was still an eraser, golden. Okay. Next remarkable thing about plotting points is this. I'm gonna need you to label all your axes and give things titles. So, label all axes. Oh, axes is the plural for axis. Label all axes. Be specific. Titles are best, too. And then scatter plots reveal minimums, maximums, increasing, decreasing. They just reveal things, traits about the data that you hadn't seen before. So, they reveal minimums, maximums, increasing. Is it going up? Is it going down? Increasing. Boop. Decreasing. Trends. Is it a bumpy road? Even as I look at the change in the COVID number of cases and number of deaths in our state, I noticed that it is doing this cyclical trend that I just keep watching to see, and it's a weekly trend, by the way, but nonetheless, having the bar graph and having a scatter plot reveals those things to the reader, to the researcher, to the public. Let's see, scatter plots reveal minimums, maximums, increasing, decreasing, data trends, range. And I'm just going to put etc. because maybe there's something that you will get out of it too. All right. As a quick summary. So, you go from raw data, but you make sure that these two values, they correspond to each other. So if they're going to correspond to each other, then you have to use a pairing to keep track of that relationship. And then when you plot that, you use that relationship in order to give a location on this grid. It's like playing Battleship, kind of. And when we do all of that, we really do that a lot in order to see these relationships that just burst out of us from the picture. So the visualization is quite helpful when it comes to revealing relationships between two quantities, which I should see a label for. So time and the price per gallon, what is the relationship there? How is it what's happening over time. So, plotting points really just allows us to make scatter plots, and scatter plots reveal all kinds of trends in the relationship between two quantities.